In this module, we are going to discuss about law of chemical combination. Certain laws are applicable when a reaction is taking place. Such laws are known as the law of chemical combinations. There are basically 5 types of chemical combination laws that always hold good during the reaction. Joseph Louis Pauwels analyzed different sources of several compounds. He found that they always contain the same ratio by weight of their elements. Table salt, for example, always contain 1.5 times as much chlorine as sodium. He also found that water always contained 8 times as much oxygen as hydrogen. Finally, he found that the mineral known as cinnabar always contained 6.25 times as much mercury as sulfur. These results lead Pauwels to propose the law of constant composition, which states that the ratio by mass of the elements in a chemical compound is always the same regardless of the source of the compound. As per the law of constant composition, pure compounds consist of the same elements in identical mass proportion. In a generic sense, a compound has combinations of the same elements with the same proportionate mass. The law of constant composition is also referred as the law of definite proportion. The law of constant composition forms the foundation for stoichiometry along with the law of multiple proportion. Stoichiometry refers to the quantitative relation of products and reactants in a particular chemical reaction. This again is done in terms of the masses, ratios, and volumes. According to the law of constant composition, the aim is to look at the nearest ratios of elements in the compound. This law is also used to find out whether the same elements are combined in making the specific compound. The law of constant composition states that sample of a pure compound always contain the same elements in the same mass proportion. To know the practicality of the law of constant composition, we can consider examples. Let us look at the extraction of carbon dioxide. Carbon dioxide can be processed by burning carbon. It can also be done through heating of limestone or applying HCl to marble. By practicing any of these, carbon dioxide is extracted. When we apply the law of constant composition definition, all the methods would give in carbon dioxide will be in the same ratio, that is 3:8. For instance, pure water that is obtained from a river or a pond is taken to the laboratory to illustrate the law of constant composition. While proving the law, pure water is found to be composed of the same elements as water. Here, the ratio between hydrogen and oxygen is 1:8. Therefore, this implies that the mass ratio between elements of pure water is the same. The compound cupric oxide may be prepared by any one of the methods, by heating copper in oxygen or by dissolving copper in nitric acid and igniting the cupric nitrate formed. In both the cases, the ratio of copper and oxygen by mass is always constant. The law of constant composition does not apply to all the compounds. Wustite is a type of iron oxide. It is a non-stoichiometric compound. Non-stoichiometric compound is not subject to the law of constant composition. Hence, this law cannot apply to wustite. This law is not applicable when there is no possibility of making two or more compounds from the same elements. Both ethyl alcohol and dimethyl ether have the same chemical formula C2H6O. The elements carbon, hydrogen and oxygen are present in the ratio 12:3:8. This ratio is given for the two different compounds, ethyl alcohol and dimethyl ether. Law of constant composition fails in the case of isotopic elements. We know isotopes are atoms of the same elements having same atomic number but different mass number. Law of constant composition cannot be applied to isotopes. Next we see the law of conservation of mass. In the 17th century, chemists accepted the definition of an element as a substance that cannot be broken down into a simpler substance by ordinary chemical means. It was also clear that elements combine with one another to form more complex substances called compounds. The chemical and physical properties of these compounds are different than the properties of the elements from which they were formed. There were questions about the details of these processes. In the 18th century, very little was known about the science of chemistry and how chemical reactions occurred. One of the leading chemists of the time, Anthony Lavoisier, became very interested in reaction and in particular the conservation of the reactants. He was the first person to name certain substances, elements, and arrange them on a table. He named the element oxygen as part of his research focused on combustion. Ultimately, his research and experiments lead to the development of the theory that mass is conserved in a chemical reaction. Law of conservation of mass states that during a chemical reaction, the total mass of the product must be equal to the total mass of the reactants. In other words, Mass cannot be created or destroyed during a chemical reaction, but it is always conserved. To know the practicality of the law of conservation of mass, we can consider few examples. If heating 10 grams of calcium carbonate produces 4.4 gram of carbon dioxide and 5.6 gram of calcium oxide. Show that these observations are in agreement with the law of conservation of mass. Let us find the answer. As we know that mass of the reactants is equal to mass of the products. Here reactant is calcium carbonate. Carbon dioxide and calcium oxide are products. 10 gram calcium carbonate is taken and it is heated. Thereby 4.4 gram carbon dioxide and 5.6 gram calcium oxide are produced. Hence, we can write 10 gram of calcium carbonate is equal to 4.4 gram carbon dioxide and 5.6 gram calcium oxide. When we solve this, we obtain 10 gram reactant is equal to 10 gram products, because the mass of the reactant is equal to the mass of the products. The observations are in agreement with the law of conservation of mass. Example 2. Sodium carbonate reacts with ethanoic acid to form sodium ethonate, carbon dioxide and water. In an experiment, 5.3 gram of sodium carbonate reacted with 6 gram of ethanoic acid to form 8.2 gram of sodium ethonate, 2.2 gram of carbon dioxide and 0.9 gram water. Show that this data verified the law of conservation of mass. Let us answer this question. We know sodium carbonate plus ethanoic acid is equal to sodium ethanoate plus carbon dioxide plus water. Substituting the masses of the compounds, we have 11.3 gram reactant is equal to 11.3 gram products. Hence, the conservation of mass is verified. Example 3. What happens when 4.2 gram of potassium chlorate is heated to give 1.92 gram of oxygen and 2.96 gram of potassium chloride as the product? How this reaction follows the law of conservation of mass? The reaction for the given case is given as potassium chlorate gives potassium chloride plus 3/2 oxygen. Here the total mass involved from the reactant side is equal to 4.2 gram and the total mass involved from the product side is equal to 4.98 gram. The 4.98 gram is obtained by adding the mass of potassium chloride and mass of oxygen. When we look at the answer, we can find the mass of reactant is less than mass of the products involved in the reaction. Hence, the given case does not follow law of conservation of mass. Example 4. Water is formed by the combination of hydrogen and oxygen. A water molecule is created when hydrogen and oxygen combine in a 2:1 ratio to generate 2 moles of the molecule. That is, 1 molecule of water with the chemical formula H2O2 has a molecular weight of 10. This is formed by the elements hydrogen having a molecular weight of 2 along with oxygen with a molecular weight equal to 8. Therefore, the mass is conserved. Example 5. When 12 gram of carbon is burnt in the presence of 32 gram of oxygen, 44 gram carbon dioxide is formed. The 44 gram carbon dioxide is equivalent to the summation of the amount of carbon and oxygen used. Therefore, the mass is conserved.